Hello class, this is Dr. Wessel, and this is a tutorial on using dimensional analysis to convert units. In our first problem, we're asked to find the number of centimeters in 1 kilometer, and so we'll need to use the metric conversion factors that you've learned. I've included here the table for you, which includes all the metric prefixes we have learned, and their conversion to a base unit, in this case, meters. We might also be using the base unit grams, liters, or seconds in future problems. In this problem, we're asked to find the number of centimeters in 1 kilometer. You always want to start with the amount that is given. So we'll include that here. Now 1 kilometer has no unit in the denominator, so I'm just going to write this over 1. Now our first step is to cancel the unit kilometers. So we're going to choose the conversion factor that converts kilometers to the base unit of meters. That's this conversion factor. Now once we've identified the conversion factor, we get to choose which part of it we place on the top and which part of it we place on the bottom. Now in this case, we want to cancel kilometers. So we're going to place 1 kilometer in the denominator and 1,000 meters in the numerator in our next step. As you can see, now we are able to cancel the unit of kilometers. But we're not done. We still have to get out of the unit of meters and into our final unit of centimeters. So we're going to look here in our metric conversion factor table and identify the conversion factor that we need. And in this case, it's 100 centimeters is equal to 1 meter. We're going to enter that conversion factor in the next step. In this step, we need to cancel meters. So when we look at our conversion factor, we decide that we're going to place the 1 meter in the denominator and 100 centimeters in the numerator. And in that way, the unit of meters will cancel. So at this point, we decide that we're left with a unit of centimeters, and that's what the problem is asking. So now all we have to do is solve it. You can use scientific notation to solve this problem easily. Ignoring the units for a moment and realizing that when you multiply fractions, you multiply all the numerators across and get a new numerator, and you can multiply all the denominators across and get a new denominator, and then divide those two to get your answer. Well, using scientific notation, we can see that 1,000 can be rewritten as 10 to the third power, and we still have 100, which can be written as 10 to the second power, and that's all going to be over 1. Because 1 times 1 times 1 is 1. Now, when we multiply 10 to the third times 10 to the second, that becomes 10 to the fifth. And the unit is centimeters. So that is our final answer. 100,000 centimeters is equivalent to 1 kilometer. Let's try a harder problem. In our next problem, we're asked to convert 0.54 milliliters to units of microliters. So the first thing to notice is that the base unit we'll be using is different. It's liters. So in these problems, we'll need to use metric conversion factors, but realizing that all of the base unit here will be liters. So how do we get started? First, you'll want to write the given and include it over 1. 0.54 milliliters over 1. Next, you'll need to identify a conversion factor that's going to get you out of the unit or prefix of milli and into the base unit of liters. So milli is down here. We'll circle that. And we'll use this conversion factor with prefixes milli, but with the base unit of liters. So in the next step, we want to cancel milliliters. There are 1,000 milliliters in 1 liter. As you can see, the unit of milliliters cancels. In our next step, we'll want to cancel units of liters and get into the desired unit of microliters. So our micro entry is here. We'll identify that and circle the conversion factor we'll be using. And that's 10 to the 6 micrometers is equal to 1 meter. Now we're in base units of liters, so what we'll enter here is 1 liter, and there are 10 to the 6th microliters in 1 liter. Once again, we can cancel units, in this case liters, and we'll be left with the unit of microliters that we've been looking for. All we have left to do is the math. So I suggest that, again, you multiply all the numerators and get a new numerator. We'll write those values here, actually. 0.54 times 10 to the 6th. We're just going to leave out the units to be able to do the math. In the denominator, we have 1,000, which is basically 10 to the 3rd. Now this problem can be made simple because we can divide values with exponents. You subtract. So this becomes 0.54 times 10 to the 3rd, because 6 minus 3 is 3. But this number still is not in correct scientific notation form, so we have to clean it up a bit. If you think about the 0.54 part, it could be rewritten as 5.4 times 10 to the negative 1. That's just this part. And we still have times 10 to the 3rd here. So our final answer becomes 5.4 times 10 to the 2 microliters, which is 540 microliters. Let's try another problem. In our next problem, we'll convert from the speed of 20 miles per hour to meters per second. Now this problem is more challenging because miles is an English unit, whereas meters is a metric unit. So I've included here for your use some conversion factors that could be useful. Let's start the problem. We'll start by writing the value that is given, 20 miles per hour. Now you have to be careful because per means the dividing line. So it means that we need to write 20 miles over, that's the per, 1 hour. And that's the amount that we're given to start with. Now we have to cancel first the unit of miles. And we would like to get into units of meters. So in order to cancel miles, we have to look at the conversion factors in length. And the two that have miles in them are one for miles to feet and one for miles to kilometers. So we don't have a conversion factor that takes us directly from miles to meters, but we have one that takes us from miles to kilometers, and from kilometers we can get to meters. So that's the conversion factor that we need to use first. Let's enter it here. Now we want to cancel miles, so we're going to put 1 mile in the denominator and 1.6 kilometers in the numerator. And in that way, miles will cancel. In the next step, we want to cancel units of kilometers and get into meters. As you may recall, that conversion factor is that for every 1 kilometer, there are 1,000 meters. Now units of kilometers can be canceled. Now at this point, if we stopped our calculation in terms of units, we would have meters in the numerator and still hours in the denominator. So we're not done with our problem, and we're just going to keep on going and canceling to get rid of hours and get into seconds. So in the next step, we're going to identify the fact that we know for every 1 hour there are 60 minutes, we'll enter that here. Now, we have to cancel hours. Hours is over here in the denominator. So when we enter this conversion factor, the 1 hour will have to be in the numerator and 60 minutes will need to be in the denominator. 1 hour is to 60 minutes. In this way, units of hours will cancel. Our final step will be to cancel the units of minutes and get into seconds. So we'll be using this conversion factor. Now in that step, we want to cancel minutes, and minutes are in the denominator here, so we're going to put 1 minute in the numerator and 60 seconds in the denominator. And now minutes will cancel. So looking at the units that we have left, the only unit in the numerator we have is meters, and the only unit in the denominator that we have is seconds. So that was the unit that we're looking for. So now we're ready to do the math. To simplify this problem, I suggest that you rewrite and then multiply all the values in the numerator. So 20 times 1.6, let's put these in parentheses, times 1,000, let's write that as 10 to the third, all over the product of all the denominators. So 1 times 1 times 1 is 1, and 60 times 60 is 3,600. Now I suggest you use your calculator for this part, and when you do, you will find the answer to be 8.9 meters per second. So 20 miles per hour is roughly 8.9 meters per second. Let's try one final problem. In our final problem, we're asked to determine the number of milliliters in 1 cubic meter. First, let's consider what a cubic meter looks like. 1 cubic meter is a box that is 1 meter by 1 meter by 1 meter. This is 1 meter cubed. Now, 1 centimeter cubed is a little tiny box that is basically 1 centimeter by 1 centimeter by 1 centimeter. So this is 1 centimeter cubed. Now in our problem, we're asked to start with 1 cubic meter and get into units of milliliter. And I've included here for you the fact that 1 milliliter is equal to 1 centimeter cubed. So let's start the problem by writing what's given. We'll write 1 cubic meter in shorthand form. That's 1 meter cubed over 1. Now I don't know how many centimeters cubed are in a meter cubed, but I do know that there are 100 centimeters in 1 meter. So what I'm going to do here is I'm going to enter that fact, 1 meter is equivalent to 100 centimeters, first. Now, meters cubed will not cancel entirely with meters. So what we'll need to do is to cube our conversion factor. We're going to cube the numerator and also the denominator. And in that way, meters cubed as a unit will cancel. Now when we do the math, we'll have to be careful because this 100 will need to be cubed, and centimeters will also be cubed. Now in our final step, we want to cancel units of centimeters cubed. So we'll include here that 1 centimeter cubed is equal to 1 milliliter. And that was given here by our conversion factor. So now we can show that centimeters cubed as a unit cancels, and now we're just left with doing the math. In the numerator, we have 1 times 100 to the third power. Well, that's basically 10 squared, that's 100, to the third power. That gives us 10 to the sixth. And the unit is milliliters. So, what that means is that there's 1,000,000 milliliters in 1 meter cubed, or 1 cubic meter. Well, I hope you found this tutorial to be helpful, and I look forward to seeing you in class soon. Thanks for listening.